In a previous video, I created some datum curves using equations with a Cartesian coordinate system. In this video, I'm going to use a cylindrical coordinate system instead, and a lot of times they can be more fun. To create my datum curve, I'll go to Datum, Curve, Curve from Equation, and from this drop-down list, I'll change Cartesian to cylindrical, and then pick my reference coordinate system. I'll just use the default coordinate system. And then we'll click on Equation, and here in the little help dialog box it tells us that you're going to write your equations in terms of r, theta, and z, and a fourth independent variable t. So, for example, let's start off with r going to be equal to a constant value, let's use 10, and then theta is going to be equal to t times 360, and we'll start off with z being equal to 0. When I click OK, you can see a preview of the curve. And this is just going to be a circle. It's got a constant radius. Let's go back to the equation. And if we want to play up with this, we can choose to change some of the values. So for example, maybe I'm going to make z equal to a value of t. And we can multiply theta times some value. Let's multiply this times 4. Then when I click OK, you'll notice that we're starting to get basically a helix. And if I go to the equation, let's make t times 4 and click OK. And there you can see it's spaced out a bit. All right, let's start off with some more fun stuff. And let's zoom in. There we have our first curve. Let's hide it. For the second one, I'm going to create something called a cardioid. So let's create datum, curve, curve from equation, change to cylindrical, pick our reference coordinate system. And for the equation, this is going to be r is equal to sine of 360 times t minus 1. And theta, again, is going to be equal to t times 360. Theta is often equal to t times 360 for these different curves. And I'm just going to offset it a constant value of 5 in the z direction. Click OK. And there you see what the cardioid looks like. We can go back to the equation, and to make the entire curve bigger, let's multiply this entire thing by a scaling factor. So there's the cardioid. The reason it's called a cardioid is that it looks like a heart in this case here because of the coordinate system. It is an upside down heart. That's good for the second one. Let's hide that one. And the next one I'm going to create is something that's called a, I'm not sure if it's limacon or limason, but let's create our datum curve, curve from equation. Just to show you how that is spelled, let's change the name of this feature. Limacon. Change the coordinate system to cylindrical. For the reference, let's pick our default coordinate system. And for the equation of this one, we're going to write r is equal to, and let's use some factor like 4 plus, and then I'm going to use 8 times the sine of t times 360, and theta, again, as usual, t times 360. And let's offset this in z distance, just to move it away from the other curves. Z equals 10, click OK. And there you see what the limacon, I'm going to call it limacon, looks like. Here we have a loop, and if you play around with the values, for example, let's change this 8 to a value of 6. You can see how it affects the size of the curve and the inner loop as well. For example, Change that. And the closer that the two factors that we have here get to one another, the smaller the inner loop gets. But the greater the difference between the two, the factor between the two, for example, let's change this maybe to 16. You can see the bigger the inner loop gets relative to the rest of the curve. All right, next one is a curve called a rose. And let's go to Datum, curve from equation, and again, cylindrical, pick our reference coordinate system. For the equation for this one, r is going to be equal to, let me actually create some additional variables like I did the other time. Let's use a as sort of like the size of our feature. Let's use a value of 10. And then k is going to be a factor for the number of petals in our rose. And let's start with a value of 3. And so r is going to be equal to a times the cosine of, and if you have an odd number for the k factor, sometimes it won't work. So I like to multiply k times 2 just to make sure that I always have an even number. 2 times k times t times 360. And again, our theta is equal to t times 360. Z, let's make that value of 20. And just to offset it from the other curves. And click OK. And so there you see our rows over here. And we can play around with the value in here. So for example, change this k to a value of 1. Click OK. And let's change it to a value of 2. There we go. And the last one that I am going to do is called the Archimedean. So datum, curve from equation, change Cartesian to cylindrical, pick our reference coordinate system, and let's define our equation. And this is going to use two different factors. We're going to have a factor a. Let's make that, we'll make that a value of, let's do 10 to begin with. I'm going to change it to 0 later on. And then we have a b factor, and b, let's have that equal to 2. And so r for the Archimedean is equal to a times, plus a plus b times t times 360. And then theta again is equal to t times 360. And for the z value, let's initially give that a value of 30, but I'm going to play around with the z value in this one. So let's click OK. And when I zoom out, that's the Archimedean, which sort of looks like a golden spiral. Let's turn off some of our other datums in here so you can see what it looks like. Now when I go back to the equation, if I multiply theta times some value, let's start multiplying it by 2, you'll notice that we get another loop going around here. Change that from 2 to a 10. Again, a lot more loops. And for the equation, now if I start multiplying or adding a factor with t times, let's say 10, and click OK, there we go. You can see that this ends up being the Archimedean spiral in 3 dimensions, so we're getting height to our cone that's being created even bigger. And with different curves like these, we could use these for creating features like sweeps. Let's create our sketch. I'm going to do a circle. Hit the check mark, And there you see our coil that's created around here. So again, datum curves with cylindrical coordinate systems can be a lot of fun and can force you to go back to the math book and pull out some information that you might have missed the first time around in your education. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.